Hi and welcome to Optimization Lab. My name is Max. I'm Master of Science in Industrial and Systems Engineering. I've been studying and working in the industrial engineering field for the last 11 years. And in this video, I'm gonna break down what you will learn after studying industrial engineering. I would break it per each year of studies in bachelor's degree. I'm gonna add my personal experience and knowledge across the video, so stay with me. We're gonna answer multiple questions. What type of personality best matches this degree? An overview of the jobs you may occupy in the next years and the pros and cons of this major. By the way, this video is an overview looking into this major. I have another video, a full depth analysis of the industrial engineering in 2025. Is it worth it? Is it not? You may find the video link here. So let's start with the personality. The industrial engineering is a problem-solving major like other engineering fields, but it has slight differences. For example, you are an optimizer, a person who needs to have a mindset of optimization. So it's suitable for people who are naturally enjoying solving puzzles. People who are attracted to mathematics and applied mathematics, meaning getting whatever we had in math and put it inside your daily life. Or maybe you're someone who naturally has the ability of thinking in a systematic way. You like to optimize everything in your daily life. You're attracted into business and manufacturing and operations. And finally, if you're someone who gets bored easily by ordinary things, you're seeking novel and maybe adventurous things in your life.
Dopamine's main role.
Well, the other engineering fields also are good problem solvers, they're innovative persons, but the thing that is different in industrial engineering is that you learn from anything related to business, related to manufacturing, related to optimization. I mean, for example, an electrical engineer is only focused on electrical systems. Mechanical engineering is only focused on mechanical parts, mechanical tools, mechanical manufacturing. But the industrial engineer can work with the electrical engineer, can work with the mechanical engineer, can work into aerospace fields, and the sea has no shore for industrial engineering. This would bring multiple opportunities and also multiple cons that I will discuss later in this video. Okay, let's get back to our track. What does the first year look like for an industrial engineering student? While there might be some differences in the stuff that I will present to you based on your location, about your university, your college, but the core idea is the same. In the first year, you will learn about basic calculus, statistics, probability, and mathematical things. The first year is dedicated for building your engineering core or foundation. These will form your engineering thought and the way of thinking, solving different problems, and learn how to best tackle a problem that you don't have any information prior about it. However, after your graduation, you may notice that in the job occupation that you might have, you can directly apply the statistics, the probabilities, the mathematics that you will learn at the first year of your studies. So it's not something arbitrary like I need to only study this and pass the exam in order to progress my engineering. No, it's not like that. Next, you will learn about micro and macro economics. This is where the cost feature enables in your mind. This is a core and foundational thing that sets apart the industrial engineers versus other engineers. While other engineers may focus on the best technology, on how to develop the best prototype, the industrial engineer acts as a valve and says, okay, this has too much cost and it has no opportunity for us. So it's like a differentiator between the different ideas. So as you can see by now, it enables you to be a decision maker, which is a important thing in the business world. After that, the next major course taken in the first year is programming language basics. For example, you may be taught about Python and maybe C++ or C or any different language about programming according to where you study. The core idea here about learning a new programming language isn't to make you guys a software engineer. That's not the point. The point here is to enable you guys to think differently, to think systematically. When you run a code, there are sequence steps that need to be taken in order to gain the perfect outcome. By the end of the first year, you are someone who knows about math, statistics, probability, you know about economics, and you also know about programming. Imagine what a beast you will look like. I'm sure that you heard about AI enough in your daily lives. You work with ChatGPT, you work with Gemini, you work with different AI solutions daily basis. The core foundation behind these AI models isn't just something out of the space or rocket science. It's the basic statistical probabilities and mathematical optimizations. Now let's move on to the second year. This year is about systems and processing. Here you are a little more attached to the manufacturing, to the processes, to the factory settings. This is where you expose mostly to these concepts. Now there are some major courses here. You have work studies, time and motion, ergonomics, operations management, production systems, and quality basics. If you look closely to these titles are job titles that you can now search on LinkedIn. So be careful about the courses that you're taking, because there are foundations of the jobs that you may occupy in the later years after graduation. By studying these courses, you may develop a taste for some aspects or some sectors of the industrial engineering major.
6 foot, money.
For example, whenever you take a course for supply chain, you may say, wow, I really like this. So by the end of the second year, you can see the stuff behind everything. For example, this microphone here, I can think about the processes, the materials, the personnel, the different systems, for example, quality system, planning system, the logistics system, the sales and marketing systems that work together in order to make this product available on the market so I can buy it as a customer. Now let's move on to the third year. The third year is when the optimization happens. You will learn about the optimization models, the operation research, core logics and functions and ideas and problems, and analytics. This is about when we optimize something, what is the outcome, how to interpret it for the others, and how we can use applied mathematics. Don't forget, the optimization is applied mathematics. So you will learn about linear programming, maybe integer programming, simulation, inventory models, forecasting, statistical quality control, supply chain fundamentals, project management. So by the end of the third year, you can model a problem or process into mathematical operations and solve it for the optimized values. This is fascinating, huh? As an example, you model a pricing problem, like demand function with price equals to revenue. Then you will use your optimization knowledge to optimize the revenue for the perfect price. This is what typically pricing experts do. And as you can see, this is a real life example of optimization, modeling, and mathematical operations. Moving on to the last year of bachelor's, this is about specialization and real world integration. You see, in the fourth year, you have multiple ways or approaches to continue your last year of studies. The first one is to take a business approach. The second one may be to take a deep mathematical approach based on the elective courses that are available based on your university or college. Let's see what do we have on the table. You may continue your studies as an advanced operation research studies, that is pure mathematical operations, modeling, solving methods, etc. You may move to data analytics and machine learning if your university allows. You may be leaned toward the manufacturing processes like quality engineering and Six Sigma, or maybe logistics. Also, you can touch down the business side. You may be interested into management, into marketing, into financials, and the courses might be available for you and you may choose based on your personal preference. At the end of your last year, you have to do a capstone project. This is a project that you need to utilize all your knowledge across these 4 years to create a problem, solve the problem, and bring in with the results.
I don't want peace. I want problems always.
As an example, my own capstone project back in the day, I think it was 2018, was to design a factory that processes the stevia plants with 300 tons capacity per year. For this project, I can remember that I designed a manufactory, the processes, the production line, the capacity management, the staffing needs, the financial calculations, break-even points, the whole 0 to 100 of developing a manufacturer was done by me. But typically, this is about designing a system from scratch, like manufacturing, as I said, for myself, or maybe optimizing a current system. This can be done by some contracts, for example, from industry with your university, college, and you will go into a manufacturer or a service provider, take one of their problems and optimize the problem in order to gain better results. For example, optimizing the process of a manufacturer in order to reduce cost or reduce the waiting time, reducing the bottlenecks. This can be a final project, but a simple one. Now let's talk briefly about the job overview of the industrial engineering. So as you saw before, we have a variety of courses, a variety of different subjects, from programming language to the manufacturing, to the mathematics, to the project management, to the quality things. So it enables you to participate in multiple job positions later after your graduation. The first sector that you may be interested to work based on today's trends is AI sector. So the AI sector can be occupied by you guys as data analyst, BI specialist, or ML engineer. This is a more advanced AI sector job. Also, some people may hate the AI and love the manufacturing, so you guys might be interested into operations analyst, operations management, supply chain rules, logistics experts, like procurement management rules, like production planning, like logistics and inventory planning or specialist. And I will guess that some of you guys will hate the manufacturing as well, and you are more leaned toward service sector. So things like process improvement, lean rules, project management, HR, ergonomics, maybe marketing, sales, this can be all achieved through service sector. It can be into manufacturing, but is mostly into service sector. And finally, we have the miscellaneous or MISC. This is the job titles that are vague and can be explained to your dad. For example, myself,
Let's see Paul Allen's card.
I'm currently working as an applied scientist in an agent building company, and it is very hard for me to describe what I'm doing for my parents, to relatives, to friends. They can't understand what the fuck is applied scientist. You see, what I'm doing in my current job is that I model the processes. I work close with the DevOps team, those guys who are in charge of deploying the code into the website, into the product. And I design the logics, the math behind the stuff you see in your daily life. For example, the website, the service that works in a website, the pricing, the ERP system. The other days, maybe I'm researching new stuff and new technologies to bring into the processes, to bring into the products. So the MISC part is about jobs that can't be labeled like regular jobs. These are jobs that are created based on the needs of the current market situation. Now that we have a general idea of the industrial engineering, let's review the pros and cons of this major. There can be always everything very good, advantageous, and with no shortcomings. It has some cons as well. Strong analytical skills, active problem solvers, system understanding, and optimization mindset. These are your core differentiators between others. You see things differently, you're looking for optimizing, you're the best guy for problem solving, and you know about everything. So, as an example, I can recall that I was working in a manufactory as the head of the industrial engineering unit, and whenever something pops up, for example, a new problem in the production line or in the customer side, or something that no one can or no one was able to tackle the issue, they would come to the industrial engineering unit. They would discuss the problem, give us a time, and we would get back with the options or the decisions or with the solutions to tackle that problem. You see, this is the core idea of industrial engineering. You're the guy that can solve problems that no one else can. If you look closely, you can see this mixture can equal to AI proficiency. You see, the AI is dangerous, I know. It can be dangerous if you overlook the potential and the power that the AI can bring to you and you can deploy into your business or wherever you work at. So if you're a good problem solver, if you have optimization mindset, if you have enough information about different aspects of any problem like manufacturing, service, or marketing, business, everything, and you have strong background in analytics and mathematics, you are the perfect guy to become the AI officer of wherever you work at. You see, the software engineers are also people who are good at AI, but what they lack that you guys can be very powerful in that area is the knowledge of business or the domain knowledge. You know about manufacturing, you know about business, you know about economics. They do not know about these things. I mean, believe me, whenever you talk with them, they are very proficient in their technical abilities. There's no doubt in that. But when you talk about different stuff with them, their mind will generate some errors. I mean, literally, when you're talking to a software engineer who is proficient in AI, and you ask about, for example, how to optimize the production line.
Like my mouth I couldn't even open my fucking mouth.
So if you can use your knowledge, you can also use the AI, and you can mix these two together. You cannot be replaced any soon. But don't get too excited. There are some cons and maybe major disadvantages as well. The first and foremost thing in industrial engineering is that you guys cannot build stuff. So if you're someone who likes to build things, this major is not for you. The industrial engineer's core idea is to get a current system and make it better. This course will not tell you or will not educate you about how to build a system like electrical engineers do or mechanical engineers do. They learn about making things. You will learn about optimizing things. The second problem that I have suffered enough from it is that you will struggle to find your path. I mean, imagine you are arriving at a restaurant, and the restaurant only serves 3 kinds of food. You can easily decide, I want this food and with this drink, for example. On the contrary, you step in a restaurant with 1,000 items on the menu. You may be struggling for days and you may starve to death about what to choose, what to eat. This is about industrial engineering. Welcome to the party. After learning about everything, you will also love everything. You will love to be the optimizer in the IT sector, in the manufacturing, in the maybe fucking police officer, everywhere. You like to be everywhere, and that may cause some major problems. You can be someone who jumps from this branch to that branch every year and hurts your resume at the end. Maybe, I'm not sure, but it can be challenging to find the perfect path for yourself. So it's very, very complicated, and be careful with the coaches that you have. A coaching can be very useful in designing your perfect path for your optimized outcomes in industrial engineering. Third is the heavy competition you guys will face. I mean, come on, you like to be in the IT sector. The IT sector also attracts guys who are graduated from the IT sector, and you will face competition from there. Also, you're looking into maybe project management jobs in the construction. And interestingly, there are some civil engineers who would like to join there as the project manager. And in every field, I mean literally every field, you will face some outside competition. Not only inside from the other industrial engineers. There are some outsiders that will compete with you guys for the job opportunities. This even gets worse when you step into the business side. The business side has a flood of people from MBA, from business schools that are competing with you guys for your job opportunities. So the competition is very high. Most other fields like electrical engineers or mechanical engineers, they do not face outsiders. Like a civil engineer cannot be a competitor for a fucking electrical engineer. That's not how it's done. But an industrial engineer can be a direct competitor for the civil engineer, for the maybe even software engineer, for the business management. There are some crazy stuff happening. And finally, you will be considered as an imaginary engineer by your peers. I mean, believe me, it's not a fucking joke. You see, how the others perceive the industrial engineering is that it's a game, it's a joke. I mean, others will perceive you as not a real engineer. You cannot build things. You are not a legit engineer. But the funny part is that those guys who were laughing at you and were maybe trolling you for your industrial engineering major will beg you later in life, after you have joined the company, for maybe job opportunities that are available, and you are going to manage those guys. I mean, believe me, I can recall that I was the head of industrial engineering unit, and a direct reporter or someone who will worked under my supervision was the mechanical engineer. The final idea here is that don't listen to those guys. Those guys that will troll you or say stupid things to you, they will have to need your confirmation later in life for their job to be passed and maybe be confirmed. So it's not an imaginary engineering thing, and it's a real engineering, and it can be even more powerful in the later years with the coming of AI. Okay, this was for today's video. Let's cut the chase and leave your thoughts in the comments for me. If you have any questions, I'm open to answering them. Let's connect on LinkedIn and stay optimized each day. Good luck.